This is a DC alternator with a rotating field coil with internal rectification. It's been sectioned so you can see the inner workings of it. It's taken from a small vehicle, but it's fairly similar to the type of alternator found in a light training aircraft like a Cessna 152 or a Piper Warrior. It has a rotating field coil, often referred to as the rotor, and it has a stationary armature coil, often referred to as the stator. Now the field coil is connected to these two slip rings, which in turn are connected to the brushes here. Initially 12 volts from the car battery or aircraft battery are presented to the slip rings. This in turn energizes the field coil, making this into quite a powerful magnet, and that magnet rotating against the stationary armature coil is going to induce an EMF in the armature coil. The armature coil is very thick windings because the armature coil of course is carrying all the current, and the rotating field coil made up of many hundreds if not thousands of turns of light wire, much thinner wire. The voltage regulator would be connected in series with the field coil. So as the RPM of the engine increases, without a voltage regulator, that would mean the output of this alternator would increase, and that wouldn't be acceptable. So what the voltage regulator will do, it will reduce the current going into these slip rings, which will decrease the magnetism of the rotating field coil, and that in turn will decrease the voltage output of the alternator. If the RPM of the engine and thus the alternator was to reduce, then obviously without a voltage regulator the output of the alternator would reduce, and once again that wouldn't be acceptable. So the voltage regulator will therefore increase the current into the brushes and slip rings, which in turn will make the field coil a more powerful magnet, which in turn then will increase the voltage. And as a result of the voltage regulator, by increasing and decreasing the current going to the field coil, we call that field excitation, by increasing and decreasing the current going into the field coil, we can keep the output of the alternator constant even though the RPM of this alternator is increasing and decreasing. And that's the basic principle of how this alternator works.